in symmetrical faults on a power system. In this session, we will take up line to ground fault occurs with a fault impedance ZF. That is, single line to ground fault with a fault impedance ZF. Once again, I am considering a generator. Then, in phase A, there is a line to ground fault occurs through fault impedance of ZF. That I am showing here the system diagram. It is a three-phase generator. Then it is solidly grounded through Zn. Then there is a fault is occurring at a point phase A with a fault impedance Zf. For this, you have to write the boundary condition. That is, the first thing is the fault current is nothing but Ia here. When there is a directly short circuited here without a fault impedance, at that case, whenever there is a short circuit occurs, the voltage is 0. But here, the short circuit is occurring through an impedance of ZF. Therefore, the VA is not equal to 0. Here, VA is equal to IA into ZF. That is the different conditions where voltage condition we are getting for line to ground fault with a fault impedance ZF. And once again, the IB and IC are 0 because it is an unloaded generator. But only thing is that there is a fault is occurring on phase A with a fault impedance ZF. That is, the one condition is that IB is equal to IC is equal to 0. Then IA is equal to IF. Of course, once again, the fault is involved with the ground. Therefore, the fault current IA you have to get 3 times IA naught. And the terminal voltage VA of the faulted phase VA is IA into ZF. That I am putting as a boundary conditions here. That is, the boundary conditions are VA is equal to IA into ZF. That is, the current here is IA into ZF. That is a VA. VA is equal to IA ZF, and IB is equal to 0, and IC is equal to also the 0. That is, both IB and ICs are 0. Then these conditions I am using in the sequence currents. That is IA0, IA1 and the IA2. That is, I am putting IB is equal to 0 as well as IC is equal to 0 in this particular equation. That is why here it is IB and IC. That is, I am replacing by 0 because for line to ground fault on one of the phases, then other two phase currents are 0. Therefore, IB is equal to 0, IC is equal to 0. Therefore, I am substituting here IB and IC is equal to 0. Once again, if you are solving for IA1, IA2 and IA1 and IA2, then what I am getting is IA by 3. That is, it is quite evident. It is 1 by 3. It is 1 into IA is IA. And 1 into 0 is 0, 1 into 0 is 0, therefore IA naught is equal to 1 by 3 IA. Similarly, if you are going for IA1, it is 1 by 3, 1 into IA, A into 0 is 0, A square into 0 is 0. Once again, IA1 is equal to IA by 3. Similarly, we are getting IA2 is equal to IA by 3. This is how we are getting one of the relation between the positive, negative and zero sequence currents. In this line to ground fault, once again I am getting IA0 is equal to IA1 is equal to IA2, that is equal to IA by 3. This is one relation I am getting between 0, negative and a positive sequence current. Then we will look into the voltage relation. That is, what is the voltage VA0? VA0 is nothing but I told you in one of the last session. That is, the total Z0 is comprises of a zero sequence of impedance of a generator and 3 times Zn. That is grounded impedance, that is 3 times Zn. Therefore, I is equal to ZGO plus 3 times Zn. Nothing but combination of these two is nothing but your Z0. That is I am putting here. That is, actually it is IA0 into Z0, IA0 into Z0. However, IA0 is equal to IA1 is equal to IA2 in this case. Therefore, I am replacing this by IA1. That is, IA0 is replaced by IA1 and this is total impedance is Z0. Therefore, it is minus I1 Z0. Then I am writing VA1 as it is, that is VA1 is equal to EA minus I1 Z1. Then VA2 also I am expressing in terms of I1 because it is actually it is IA2Z2, but IA2 is equal to I1, therefore I am replacing IA2 by IA1, therefore it is minus I1 Z2. These are the voltages, that is network voltages in the zero sequence, positive sequence and the negative sequence diagram. Therefore, because we know that IA0 is equal to IA1 is equal to IA2. Then, once again you can recall the boundary condition is that VA is equal to IA into ZF, or the IA can be, you can replace IA by IA0, IA1, IA2 because IA0 and IA2 are also IA1, therefore it is IA1 plus IA1 plus IA1, that is equal to 3 times IA1. That is, IA can be replaced by 3 times IA1. That is quite evident from this relation because IA0, IA1 and IA2 are same. IA0 and IA2 are replaced by IA1, therefore I am getting 3 times IA, that is IA value. Therefore, I am writing VA as 3 times IA1 into ZF. Then, I am using the sequence voltages VA0, VA1, VA2, that is nothing but VA is, that is written in the boundary condition, that is VA is equal to IA into ZF. Okay, the same relation I am using here, that is VA0 is equal to VA1 VA2, that is nothing but your VA. Therefore, the right hand side is 3 times IA1 ZF. That is VA I am replacing by its sequence voltages VA0, VA1, VA2 and 3 times IA1 ZF. Now I am substituting VA1, VA2 and VA1 from this relations. That is this VA0, VA1 and VA2 I am substituting here, VA0 and VA1. Then what I am getting here is IA1 Z0 minus IA1 Z0 plus EA minus I1 Z1 plus of, it is VA2 is minus I1 Z2 minus I1 Z2 is equal to 3 times I1 Z2. That is, my intention is to find out the fault current. To get the fault current, I want the sequence currents, that is IA0, IA1, IA2. In this case, all the currents are equal. Therefore, I am making an attempt to find out what is I1. Okay, this is from the boundary condition. What I derived here is all this, that is Z0, EA, Z1, everything is given, ZF is given, only you have to find out I1. Therefore, this expression, this unknown quantity is only I1. Just you have to take the coefficient, that is I1 terms together and the other terms on the right hand side, and you have to work out for I1. Therefore, what I am getting here is, you can see here, if you are taking I1 outside, or you can take all this I1 Z0, I1 Z1 minus I1 Z2 onto the right hand side, therefore it is there become positive. Then the EA is, you are retaining in the left hand side, then it is become a positive. Therefore, what is the coefficient of I1 you are getting? Z0, Z1, Z2 and 3 times ZF are the coefficient of I1 in the different terms. That I am clubbing here, that is Z0, Z1, Z2 and 3 times ZF. This is the value of I1. Once if you know the I1, then the fault current is 3 times I1. The fault current, that is I is 3 times I1. Therefore, we are getting directly the fault current. Also, fault current is 3 times I0 because I1 is equal to I0. You can write 3 times I0 also. Therefore, the total fault current is 3 times I1. Therefore, what we are getting here is the fault current is I is equal to 3 times I1. Therefore, I will write all the sequence diagrams. Here, the one condition what I am getting here is the IA0 is equal to IA1 is equal to IA2. This is for line to ground fault we are getting. Therefore, the currents in all the three sequence networks are same, means the positive, negative and zero sequence networks, they are connected in series. because the current in all the networks is equal. Therefore, IA0 is equal to IA1 into IA2. Therefore, all the sequence networks, they are connected in series. The same thing is shown here. This is a positive sequence network, negative sequence network, then the zero sequence network. In this case, all these are connected in series. Yes. Then if you are adding, if you look into here, that is VA0, VA1, VA2. What we are getting here is VA. The sum of VA0, VA1, VA2. What we are getting is VA. If you are basing the voltage between these two, this you are getting VA. At the same time, what is the VA? VA is 3 times. VA is 3 times IA1ZF. But the current which is flowing in the network is, that is we are representing per phase basis. Therefore, 3 can club with the ZF, that is IA1 into ZF. VA is nothing but IA1 into 3 ZF. Therefore, just you can observe here, this is a positive, negative and zero sequence, they are connected in series. The terminal voltage we are getting VA. The VA is also nothing but it is 3 times IA1 ZF. Therefore, you can look into here. That is the whatever the equation we have written, VA is equal to 3 times IA1 ZF. See, current is IA1. Here is also current IA1. Here is also current IA1. Here is also current is IA1. This IA1 into 3 ZF is 3 times IA1 ZF, that is nothing but VA, and sum of VA0 and VA2 and VA1 is also your VA. This is how you have to analyze the line to ground fault with a fault impedance ZF. Once we know the value of the IA0, IA1, IA2 and VA0, VA1, VA2, we can calculate VAN, VBN, VCN, that is line to neutral voltages under fault condition. And at the same time, once if you know VAN, VBN and VCN, you can calculate the line to line voltage, that is VAB, that is it is a vector difference of VAN minus VBN, and VBC you can calculate as VBN minus VCN, that is also vector difference, and VCA as VCN minus VCA.